Hello everyone and welcome to a altogether new discussion which we are going to start a series of discussions on groundwater exploration, which is a very important aspect in groundwater engineering, and this is the first part. So, we will see all kinds of exploration techniques based on remote sensing, geophysics, ground surveys and so on. So, this groundwater exploration discussion is going to several discussions or several videos. So, let us start the first one. First, we will try to define what is basically groundwater exploration, and that is the groundwater exploration basically involves the use of scientific methods, and this I want to emphasize here very much. Scientific methods to locate and extract groundwater. There are a lot of myths and a lot of people claim that having a coconut in the hand or some rod or other things they can locate the groundwater. It is completely non-scientific and it does not happen like this. How a coconut gets influenced through the presence of groundwater, nobody is ready to explain. And therefore, in the definition this term is very important, that the exploration involves the use of scientific methods, and scientific methods might be field surveys, might be geophysical techniques, might be remote sensing, but not having a coconut in the hand or some rod or wooden stick and claiming that here if you drill you will get the water. No, they are just fluke and they do not work like that. So, the groundwater exploration has to be scientific to locate and extract groundwater. How much water we will get if we find a location of water, and also groundwater exploration will help us to understand the aquifers nature, aquifer characteristics and type and quality of water. That is another important thing. There might be some groundwater, but if quality is poor, then we cannot use for human consumptions or even for agriculture things. So, as well as groundwater quality, which is very important, and of course, the quantity, which is how much water can be extracted, that is also involved in groundwater exploration. Whereas another term which is used which is called groundwater prospecting, and this is more specific to the various methods to locate suitable quality and quantity of groundwater for extraction. So, here purely scientific method which involves to locate suitable quality and quantity of groundwater which can be extracted from the surface or from the underground conditions. Another thing which is called groundwater investigation. So, three terms we are: groundwater exploration, which is overall everything; groundwater prospecting, more focusing on the methods which to locate and quality and quantity; and groundwater investigation, which is groundwater investigation can be generally divided into two types. One is the investigation of water quantity and water quality, and or otherwise investigation priorities depend on the project requirements and objectives. So, this kind of terminologies are being used in groundwater exploration, prospecting and investigation, but we will be more using this term which is groundwater exploration. So, groundwater exploration is a task of an engineer or a hydrogeologist to find water first. Then next start what is how much quantity of water and what would be the quality of water. So, in this task or in groundwater exploration, what we are trying to identifying the location of its availability, and that is the most challenging task, especially in hard rock terrain, which is a large part of India is being occupied by hard rock terrain. So, exploration of groundwater requires a basic understanding of its position in the subsurface geological setup. So, we have been discussing in this course what are the geological setups which can or favors the availability of groundwater. So, that is what the exploration is. So, the basic understanding, if geology or surface geological setup is not favoring groundwater, then it can become very challenging to find groundwater. But anyway, it is required. So, explorations are done, groundwater explorations are done in each and every place, whether it is a hard rock, alluvium or whatever is there, or even in mountainous terrain. So, groundwater exploration is basically attempted either by direct or indirect methods. So, both methods we will be discussing, both types of methods. Test drilling is the direct approach, but it is to find out the water resource, but it is expensive option because drilling will cost lot, and at every place it is not possible to have drilling quickly. So, this test drilling may be a very good approach of a direct method of groundwater exploration, but it is an expensive option. So, not initially the test drilling is done, but once through surface or indirect methods or a geological setup, when understanding is developed, then one can go for test drilling to make sure that the water is available as per our interpretations or estimates based on the field investigation, geological setup, maybe geophysical investigations also. So, it is not possible and that all individuals can go for all sites for test drilling, so because it is expensive. Now, in last 2 centuries, if we see the historical development of groundwater exploration, more and more techniques have been developed to explore the groundwater, and these are classified into 2 major divisions or 2 major categories. One is surface method and another one is subsurface method. Subsurface methods here basically meaning is geophysical techniques, and surface methods are geological methods and might be remote sensing methods also. So, surface methods are easy to operate and implement, and these require minimum facilities like a topographic map of the area, maybe a geological map of the area, maybe geological reports of the area, or some field measurement and interpretations of data in the laboratories. Interpretation of data here we can also include remote sensing data in this area, because remote sensing data can provide lot of indirect evidences of availability of water in subsurface condition. For example, growth of vegetation, for example, maybe some faults and lineaments and other things. So, they are the indirect evidence or indirect manifestations of availability of groundwater, which we will see in much more detail later on. And every individual, as we have seen, that cannot go for drilling, and during this is what has happened. Now, groundwater exploration are classified into, as just mentioned, surface and subsurface methods. So, in surface methods which are easy to operate and implement, and these requires minimum facilities. And now, surface methods of groundwater include the following. The first one is geomorphologic methods. So, in initial stages of finding out the groundwater in an area, topographic map is very much required. Based on topography and some field investigations, geomorphology methods can also be, like alluvial valley fills alluvials, or valleys which are filled with the sediments can become a good source of, or can become a good site for water exploration or water exploitation even. So, therefore, the geomorphologic methods are quite important under this surface methods. Geological and structural methods are, geology is again important, the surface geology if I talk, of course, subsurface is geology, but initially we go for surface methods. So, geological and structural setup is very, very important to know. So, that method can also be involved. Third one is the soil and microbiological methods, where we see that how whether vegetation is there, soil is there, because if soil is there, then there are chances the growth of vegetation, and growth of vegetation can only occur when you are having availability of water. So, that is a indirect evidence of availability of water. This I have already mentioned, the remote sensing technique by which you can cover a large area in a completely unbiased manner. So, a large area can be surveyed using surface methods and especially remote sensing and data, which is available nowadays almost free of cost from many satellites at relatively quite high resolution. So, this should be at initial stages of groundwater exploration, this should be definitely employed at the first place, even before the field investigations. And then another surface methods which can be employed is surface geophysical methods, and we will see what basically all details about the surface geological methods. So, under this subsurface methods of groundwater exploration, we will see this list also. One is the test drilling, which is quite expensive. Another one is borehole geophysical logging techniques. If you are having a drill hole, then only borehole geophysical techniques, or in short we also say well logging, can be performed. So, when compared to the surface methods, subsurface methods are very expensive. That means the geophysical techniques involves lot of instrumentation, and also many geophysical methods are based on the bore well or test drilling. So, therefore, this is very expensive as compared to surface methods. So, these subsurface or methods are mostly done by the government level projects, where large scale investigations are carried out to ascertain the results of surface surveys. So, initially you start with topography, remote sensing, geomorphology, geology, structural geology, and then if you are sure you are getting water, then you want to assess the exact quantity of water which can be exploited, then one can go for subsurface method, because otherwise these are expensive. So, through surface methods, if a large area is being surveyed, you can identify where are the more chances of getting groundwater, and then to ascertain about the availability of groundwater, then subsurface methods can be employed. But it is also true that subsurface methods are relatively very accurate compared to surface methods, and they are basically based on the direct observations of features of phenomena in the form of borehole lithologs. That is why I said through well logging, and in well logging there are different various techniques which involved in the well logging. So, that is what can be done. Core samples and also geophysical measurements of formation properties like resistivity and density, temperature, many other parameters can be studied in the boreholes, putting different kind of instrumentation inside a borehole, but creating a borehole is expensive. So, the most common purpose of groundwater investigation is targeting of water resource for, of course, for local supply and planning, local drinking water supply and planning, maybe some also industries. Optimum utilization of water resources, that is another important aspect in groundwater exploration, and the common objectives of groundwater explorations are which is one is the locate aquifer capable of yielding of various uses, yielding water, groundwater for various uses, water of suitable quality. So, quality is also important, and that should be suited. Suppose if it is investigation is being done for the drinking water, then it should be the quality of water should be accordingly the standards for drinking water. If it is exploration is done for some industries where lot of usage of water is there, then the quality of water should be suitable accordingly. Then economic quantities, how much water can be extracted and how economic that quantity is going to be. So, that is another aspect or one of the objectives in groundwater exploration. So, generally as per requirements these things are employed. First geological, geophysical, drilling, and lastly other techniques are also involved, which are as per the requirements they are there. It is many times in hard rock terrain you may not need to go for geophysical or test drilling. Based on simply surface investigations, one can be sure that the water might be available, as depend on the indirect, several indirect evidences which are indicating of availability of water. So, because it is very cost effective, so all kinds of possibilities of availability of water should be first explored through surface methods only. And if it is very much required in surface manifestations of groundwater is not there, then one should go in later stage for the geophysical method. So, what are the informations which is sought during the course of groundwater explorations? One is depth, at what depth the water would be available. So, the locations of basically water bearing aquifers and the extent of aquifers, what is the lateral length of the aquifer. Of course, one of the tests which people do, we have been also discussing pumping tests, which can give some indications about the extent of aquifers. But if exactly it has to be demarcated or to understand, then maybe few more drilling might be required, and types of rocks to be penetrated. That is another important thing. If it is a hard rock like granite or other things, then what kind of cost it will come, and whether at what depth water would be available in other thing. In simple sedimentary rocks or like alluvium in the Indo-Gangetic plain, then it is a different scenario. Quality of water, not only the quantity, but quality of water is important, and sustained yield. How long water can be exploited from such aquifers or such well. So, what would be the sustained yield from these? However, there are some other objectives of groundwater explorations which are to study feasibility of artificial recharge. This is another important thing which is now being getting more focus, is how to recharge our aquifers, so that they can provide a water all the time. So, recharge, artificial recharge generally are done through during the rainy season, monsoon time. So, for that purpose also that is also one of the objectives, but less common objectives. Disposal of industrial waste, nuclear waste. Nowadays, lot of hazardous waste and nuclear waste are being generated by the industries of different kinds. Where to dispose? If we dispose on the surface, they will pollute our groundwater regime. So, can we dispose these pollutants in subsurface conditions? So, for which also the groundwater exploration is done. So, that we find the areas where it will not mix with the groundwater. So, for that also you need in almost same way as for the groundwater exploration. So, in those areas which are having very deep aquifers, water is found at a very high depth, those areas can become, and if these are in completely hard rock terrain where permeability, transmissivity is very little, then these are the areas can be used for disposal of industrial or nuclear waste. Groundwater control for mining, etc. Like all mines, these are either subsurface mines or on surface open cast mining, and their groundwater plays a very important role, especially the groundwater in subsurface mines, where hardly you are having opening, and exploitation of minerals, rocks or coal kind of thing are done through these, mostly through subsurface mining, and where groundwater plays a very important role, and it sometimes can create many hazards or disasters also. In past in India also lot of disasters have happened in, especially in coal mine areas which are having quite good groundwater. So, suddenly in subsurface conditions inside a subsurface mine there might be flooding as well. So, therefore, it is very important from during the mining or for mining from point of view that the groundwater should be studied very carefully, so that such disasters should not happen. Now, another important or little less common objective of groundwater exploration is a groundwater seawater interaction, or we can also say seawater intrusion. Because if on the land part, if we start exploiting too much of water, groundwater, then the seawater may intrude into our fresh water, and you know the sea water is salty water, so it will have a lot of problem. And in coastal areas, lot of groundwater explorations are done just to avoid intrusion of sea water. So that is another practice which goes less important objective, but it is done. For many areas it may be a very important objective. However, before an exploration program is taken up, its relevance from the point of view of social and economic benefits should be examined to justify investment of funds. If water is very desperately required for some area, then we can afford expensive solutions, because this economy will play a very important role, whether water can be transported or should be exploited there itself. So, these 2 points, social and economic benefits, are very important before the groundwater exploration program is basically launched. Then what we follow, the technical aspects of groundwater exploration, including the schematics of operations, how it will be done. So, through a flow chart I am trying to bring what we have discussed so far, is that if assessment of exploration techniques for a particular area. So, first we also study what are the social and economic aspects of groundwater exploration, implying remote sensing and GIS. This is surface technique. Then we are employing geological field investigations, again fractures, structures, joint planes, weathered zones, etc. Like in hard rock terrain, weathered zones are very important, fractures are also important. Then hydrological field investigation, that is groundwater hydrology, hydrochemistry also, what is the quantity and quality of water. Then we might go for geophysical field investigations, which involves resistivity, MT, and many kind of geophysical techniques, and many more are based on the well logging. That data is being collected or is collected through the bore wells. Now, so after this we go for data evaluation, whatever as per the economy and the synthesis. Then site selection priority wise for test drilling, which is the most suitable site where we having high chance of water, that we will go for test drilling. It is not just like in the field where coconut has moved and you go and start drilling. No, that is not scientific method. So, once through scientific methods, once a site selection has been done based on priority, then go for might go for test drilling. Once the drill hole is available, then lot of well testing can be done, that includes pump test also, include well logging also, and then finally well completion. Once we are sure that there is a particular well will yield good amount of water, providing a good quality of water and may sustain for longer time, and then we develop the well further and do the completion of the well, means putting casing, putting pumps and all kinds of protections to that well. And this I am trying to link with this. Earlier in the beginning of this course, I have shown the same map of India, where which here it is the social and economic aspects of groundwater exploration. You can see here that 54% of India faces high to extreme water stress. So, in say in Indo-Gangetic plain, the the economic forces are not that, because you are getting water very easily, but areas where you do not have much water or less water is available, then because it is requirement for the sustainability of human and animals life, then the economic factors becomes completely different than where the water is available. So, a large part of India, that is more than half, 54% of India is facing high, which is in light red color to this maroon color, extreme high water stress, and especially this scenario is in the eastern part of India, or mainly Rajasthan and some parts of even UP also faces that problem. Further, 44% of India groundwater wells are decreasing. This is another very alarming situation in India, which you can also see that through this map. But very recently, you can also check net for this. Very recently, I have read a news like in Telangana, in past few years, they have made lot of efforts to recharge the groundwater regime, and therefore, there is a even the water table has risen by at some places by 2 meters, which is a very significant recharge and very good development, and it clearly shows that if a recharge is done systematically through in our monsoon season, then we can reduce this this scenario that is decreasing. Instead, we can have a map where a large part of India is showing wells, the groundwater in wells is increasing. So, the best solution, earlier it was shown through the several thousand groundwater recharge structures in Gujarat, where they could stop the decreasing of water level in the wells, and in some places they were even increase in the water table. So, they could stabilize the declining of water table in Gujarat. Now, very good news is coming from Telangana. So, we know that how it can be improved, groundwater situation. The only thing it is required is sincere efforts on the ground, and as shown by these recent years, these two states. So, why not other states? Because if we are having sufficient rainfall, large amount of water is going as a surface runoff and getting wasted into the sea. If we utilize that water and recharge our groundwater regime, then this decreasing trend can be inverted. This is another related thing which I want to bring here in this discussion. This is also relevant, very much relevant when we will be discussing groundwater recharge. But here, since we are discussing about the declining, so many people attribute the declining of water table is because of reduction in the rainfall. But these two plots here which you are seeing, one the bottom plot is showing the data between 1901 to 2002, and another data on the top part is being from other source. The data is 1951 to 2003. And what do you observe? What do you observe that this best fit line, and you can see this R square values are also. That means overall and the input from atmosphere of water over the India has not reduced significantly. So, why these crises are there? The question is that our requirements of water has increased significantly, but at the same time our recharge efforts have not reciprocated accordingly, and that is why these large part of India is having high to extreme high water stresses. So, like Gujarat, like Telangana, which has made efforts, and they have put this rainwater into ground through the groundwater recharge, then there will not be much problem. And news says that it has risen by 2 meters, which is very high development of availability of water, and that means the good recharge can happen very easily, very quickly. And even in later discussion, I will be showing some examples where in 1 or 2 years time the results will start coming if sincere efforts are made on the ground about groundwater recharge. And further, if you see here, you do not find much changes between 2000 to 2014 in the rainfall. Like here, the total rainfall, which is in the dark brown or yellow color, and between some years there are changes, but if you try to draw a best fit line, it will go almost straight or parallel to the years. That means the rainfall all over the India has not changed, the total amount of rainfall. However, there are few changes like the timing of rainfall has changed. In earlier discussion, we have also said the intensity of rainfall has changed. Rainy days have reduced. That means rainfall has increased, intensity of rainfall has increased. And third important point, that there are now spatial variations which are also occurring. So, one is the temporal variation is occurring, another one is the intensity is increasing, number of rainy days are decreasing, and the third is spatially, like we knew that Cherrapunji is having highest place where rainfall is received, but now it has shifted to Mohsingaon. Similarly, many parts of Rajasthan which we never heard about having floods, now they are having floods. So, especially the location of rain areas are changing, but overall total rainfall in a 1 year falling over India has not changed significantly. That means, if we make efforts, the same amount of water is available as was available in 1901. That means, as per our requirements, which is increasing exponentially, in same way if we make efforts for groundwater recharge, then we will not have 54% of area having extreme or very high, extreme poor groundwater conditions. Similarly, here if you see that annual rainfall trend, it is of course based on the political boundaries, that is the district wise, but you know that rainfall does not know the district boundaries, but anyway the data is in that sense. So, there are many areas which are shown yellow or light brown colors in some parts of Uttar Pradesh, Madhya Pradesh and Bihar and other parts where it has been decreasing. But this is the point which I was mentioning, that there are parts where it is increasing. Annual rainfall is increasing in Rajasthan, which never used to have, and we used to have lot of floods in this area, but they are now having kind of drought situation in the country. So, the spatial location of the location of rainfall is changing, shifting generally from east to west. Whether this trend will continue for longer time, we do not know. But what we know from 100 years of data or more than 120 years of data, that the total rainfall which was falling over India in 1 year continues to have the same amount, almost same amount. There is only slight decline. So, we need to have require lot of efforts to recharge our groundwater regimes, as our requirement has increased manifold, and therefore, we can maintain a good supply of water. So, it is also observed that the country's rainfall is not showing any trend, this I have just mentioned also. You see, the average rainfall over India is quite good, 1120 millimeter per year. So, if we increase our storage through groundwater recharge by 1 more percent of whatever the rain precipitation is occurring over India, that would be enough to meet the country's domestic requirements of the water. Just 1 more percent of water storage is required, and that can be done very successfully. 2 states of India have already shown that if sincere efforts are made on the ground, then one can recharge the groundwater regime and can resolve lot of crises which are occurring because of non-availability or less availability of groundwater. So, if we see the total volume of water which is falling over India in 1 year, which is annual precipitation over 4,000 cubic kilometer, huge amount of water, and whereas our groundwater recharge is just 433 cubic kilometer. So, roughly it is you can say 10-11%. So, if this 1% increase or 2, then for long time we can get rid of this water problem in the country, and that can be done. Repeatedly I am saying 2 states have shown that. Now, there are some other remote sensing based methods, and there were one mission which was the GRACE mission, that was a gravity based changes which are showing the depletion of water, especially in the northern India, and you can see that which part is showing groundwater depletion, and see these red areas. So, the western part is becoming rich and eastern part is having more depletion of groundwater. Why? Because here the rainfall is getting shifted towards the west and reducing there. So, the recharge is reduced if no efforts are made, then it is going to create lot of problems in this part of eastern part of India, where large population is there. Further, if we see the data, which is the groundwater resources of India 2020, this is in this was from CGWB. Total annual groundwater recharge is this much BCM, 436 BCM. Annual extractable groundwater resources is this 397.62 BCM, billion cubic meter. Annual groundwater extraction is 244. So, if we subtract 397 minus 244, roughly we will end up with the stage of groundwater extraction. That is what reserve is roughly, if we subtract these two values, the reserve which we are having. So, extraction of groundwater is still there, but one day it will come that annual groundwater extraction would be, if it becomes equal, then the crisis of groundwater availability in the country is going to be very huge. So, the best thing should be to increase the difference between groundwater resources and groundwater extraction in a positive manner, that we should have more resources, relatively less extraction and better conditions. Now, there are some other data sets are also available about the dynamic groundwater resources of India, again 2020 from Central Groundwater Board, and these values are million cubic meter. So, if we see different assessment units, recharge worthy area and annual extractable groundwater resources. So, how much percentage is there? Then we are having 64% which is safe, and like if I see the other extreme, which is saline, and these are the assessment areas, 1% is having saline. So, still we are do not have. If one more other important thing, if we do a regular groundwater recharge, a good groundwater recharge, we can reduce the salinity also, concentration will reduce. So, there a water which is semi critical or critical can be converted through dilution process, through groundwater recharge into the safe category, and this process can be reversed. So, that is another very good advantage of groundwater recharge. So, with this I end this discussion. Thank you very much.